Hello, everyone. Hi, thanks for coming to this session. My name is Todd Gardner from Track.js, and I have the great pleasure today of introducing our next speaker, Mr. Harrison, the Vice President of Information at Engine, the company that brought you Jurassic Park. He oversaw all the technology products during the development of that park, and he has some important lessons to share with us today about all the things they learned, about what they did right and what they did wrong during that. He's here today to share that knowledge so that we can all learn from his mistakes and his successes. In case you're not aware, Mr. Harrison fits with all of these other well-known personalities in the Jurassic Park ecosystem. Folks like John Hammond, Ray Arnold, and Dennis Nedry. So, without further ado, please welcome Mr. Harrison. Hello, everyone. I'm pleased to be here today at NDC Porto. Let me be the first to welcome you to Jurassic Park. You may have seen a documentary made about us. It received some notoriety and highlighted our issues. But let me underscore that it was grossly over-dramatized. Only 4 people died in the entire, exploration of Jurassic Park. And I think we learned a lot from the overall experiment. This talk is going to be an uncomfortably close look at the successes and few failures that we had during Jurassic Park. We put together, my team and I, this retrospective of our learnings to share with the larger community and move into the brave new world that will be the next Jurassic Park. But more on that later. One of our core problems with Jurassic Park, which we'll talk a lot more about today, was perfectly articulated by one of our consultants, Dr. Ian Malcolm. We were so preoccupied with whether we could, we didn't stop to think if we should. And he was specifically talking about our choices of software when he made this quote. So when we were choosing which software to build and which software to buy, we didn't go into that thinking our decisions through. And that's what I want to break it down for you today. We're going to talk about all the different pieces of software that we built for Jurassic Park, and then the ones that we bought, and what we should have done as we worked through that. So why would you go and build a piece of software? Well, first and foremost, when you build a piece of software, building something is unique. You are solving a problem for you using the constraints and the risk profile that you are most comfortable with in your organization. You're going to build something that's not going to handle every edge case in the world, only the ones that you think are important, and it's going to solve the problem perfectly for your needs. But probably even more important than the fact that you build something unique for you is that it's fun. We're developers, we're engineers. We want to build software that solves the problems that we want. We want to do this. We want to jump into a problem and tear it apart and try and build something. This is our natural tendency. Building things allows our developers to try new ideas and escape the normal tedium of working on our legacy systems. Building things improves your team morale, and it harnesses the passion of the people. At Jurassic Park, we were able to hire our own ace rockstar developer, Dennis, largely by tapping into his passion, which was building security and locking systems from the ground up. But as you dig past that first, problem that you see a problem described to you and you're like, I can fix this, I can do this, you quickly start getting into the details. All of the little features, all of the little edge cases that are going to get in the way. Failure modes, how you're going to back it up. What's the security needs of the system? This is where all the real costs, the real time lie in building system. And you quickly solve a problem and you're like, oh yeah, we're 80% done. But that last 20% is going to take way more time than you think it will, because it's where all of the time goes in exploring these edge cases. And edge cases are everywhere. We ran into a lot of edge cases at Jurassic Park. As we were building up our security system, which was way ahead of its time. We were doing IoT before IoT was cool, but we didn't handle edge cases like what happens if the computers go down and we can't lock the doors. There's no manual override. There's no handle in case, for whatever reason we lose power and raptors are trying to get in the door. There's no way to close the door without a computer. And that may have been an edge case that we overlooked. Another cost in building our own systems is in the maintenance time that's going to go into building your software. Bugs, patching, security, integrating it with your other systems, debugging why the headlights are running on car batteries. 1,000 annoying little tasks that are going to happen months and months after you're not interested in the problem anymore. You've already launched that first version, but you've built something, now you own it for months and months in the lifetime of the product. This is where all the true costs of building software lie, and the thing that we need to think carefully about before we decide to build our own piece of software. All of the maintenance time. It might only take you 3 months to build a piece of software, but if it's really successful, we may be maintaining it for 10 years. When we build a piece of software, we're responsible for maintaining its health, for seeing its observability. We spent a lot of time at Jurassic Park building our own monitoring tools, our own monitoring dashboards that could track everything that was going on in the system. And that in itself took a lot of time, just building the tooling we need to maintain the software that we already had. We have to spend time not only building the core things, but building all of the tooling that it takes to make sure that it's running well and make sure that it's working. And this is always going to take longer than we think to get right. It's going to take failure and iteration. You don't know what monitoring you need until the system has fallen over a few times and you figure out what the gaps in your monitoring were that led to those failures. You want to make sure that you get paged at 2 a.m. when the dinosaurs actually are out of the pen, but you don't get paged at 2 a.m. every day. Of course, maintenance time isn't going to happen when you're thinking and ready for maintenance time. It's going to happen when you've forgotten how the whole system works and you've moved on to the next exciting project. You'll have moved on to bigger and better things, and so remembering how to clear out the caches or restart the services, it's not top of mind, and you're going to have to depend on the documentation that you left for yourself or you left for your team before you moved on. And honestly, none of us really do a great job at documentation, right? It generally sucks. If it's even correct at all, it's horribly out of date and you have to fill in all the missing pieces. But this is a really important cost that we need to think about when we're going to build a piece of software and hand it off to the rest of our team to support. And an outage takes all of the stresses of digging through documentation and handling maintenance time and adds in the additional stressor of your boss shoulder surfing over looking over your shoulder, making sure you're doing it right to get the system online. Is the system back on yet? Is the system back on yet? Is the system back on yet? I need an update. Outages are going to be a core part of this maintenance time. As we all know, things don't always go as planned. Sometimes systems go down. Sometimes electrified fences go offline. Handling the recovery is part of our costs. Do we know how to restart it? Do we have to dash across the compound to flip the breaker in order to get the server back online? These are important costs to consider as we're designing a system. Now, many of you might have been familiar with the term a bus factor. There's a number of people in most software teams, but how many of them would need to get hit by a bus in order for you to lose the tacit knowledge required to maintain and recover your systems? And so an important thing to think about. If you're the only person in your organization who knows how to get a piece of software back online or how to patch it or how to add that next feature, then you have a dangerous risk in that organization that if you get hit by a bus, what are they going to do next? Now, we didn't really have buses in Jurassic Park, but we did have Dilophosauruses. And so we called it the Dilophosaurus Factor. How many of our engineers would have to be eaten by a Dilophosaurus for us to be in trouble? And unfortunately, the answer to that was 1. one of our developers had to be eaten by a Dilophosaurus, and we were kind of screwed because we didn't put the forethought into this to make sure we had redundancies in place and proper documentation available for us to recover from this developer's unfortunate incident. Having that low Dilophosaurus factor creates important sustainability issues. How are you going to help out if your teammates become unavailable for whatever reason? This can happen for lots of reasons. Or large organizations specifically tend toward creating lots of fiefdoms of knowledge, specializing a particular team in knowing about this system or that component, or these are all the database people working together. And these fiefdoms make things more efficient, but they also silo that knowledge, and they make it harder to get, beyond the Dilophosaurus factor of 1. Standards, documentation, and transparency between your teams can help a lot, but they're really hard to get right, and you can never be truly redundant. And so understanding what the Dilophosaurus factor you're creating when you embark on a new piece of software is important to consider. There was a particular project we had during Jurassic Park that we had outsourced the development of a system to 3 separate contractors. Unfortunately, there was no incentive for any of them to work well together. So they all kind of hoarded their knowledge. They knew how their part of the system worked, and they didn't want to share it with any of the other contractors and help them look good. It was unfortunate that, when one of them failed, we couldn't backfill any of them, and it was very inefficient. Later, we found this calculator, and it kind of was a good illustration of our problems. This is actually available online at baremetrics.com/calculator. And what it allows us to do is it allows us to think about our development time in terms of dollars. So we had Dennis working on a security system for us. And Dennis claimed that he and myself, he asked for some help, 2 employees could build the security system in 2 weeks, which was maybe a little aggressive on his part. But he claimed he could do it in 2 weeks, and that we would think we needed one day a month or so to maintain it, make sure it was patched, make sure everything was ready, added whatever features needed to happen. And we had a bit of a good deal on Dennis. We were paying Dennis $120,000 a year in his salary. To compare that against, we went and looked in the market and say, well, what could we buy a piece of software that would do this for? And we found that, we could license something for about $3,000 a month. And so we type all this stuff into the calculator, and what does it tell us? It tells us the actual costs that our organization will incur to build this piece of software. That 2 weeks of 2 developer time is way more expensive than you think it is. When I told you it'll take 2 weeks of developer time, how many people thought that actually would cost over $9,000? We don't think like that. We think developer time is like, whatever, it's not a big deal, we can invest that. It costs a lot of money to put highly paid, highly skilled developers on a problem. And that 1 day a month that we think is going to be required to maintain it adds up really quick. Every month we're going to lose another day of productivity, another day of focus to maintaining this security system that maybe we didn't need to buy. And so if we compare that to the $3,000 that we could buy the software for, we're never really making financial sense off of doing this. We'll lose money every year that we want to build this piece of software. But this isn't the most important cost to think about. The most important thing is, what could we have been doing instead? Every organization at its core has something that it's really good at, that it is unique at, that it is the main reason why it exists and make money. At Jurassic Park, we could build dinosaurs, giant dinosaurs, beautiful dinosaurs, scary dinosaurs, dinosaurs that could eat you alive. And that was what we were good at. We weren't so good at building security systems. That was not our core competency. And so by spending all this time worrying about that, we weren't able to build dinosaurs as big and scary as we really wanted to. Imagine what kind of things your organization could do if you'd stop spending time building all the little ancillary pieces of software that don't actually help your organization, and you pour all of your time and energy and focus into the handful of things that really matter to you. So the costs involved in building software that we need to think about is first that creation time. When a developer comes up and says, oh, I want to solve this problem, this is a great thing, I want to dig into it, that costs money. That's going to cost time for them to go off and do it. And maybe it's worth it to keep them excited, to keep them engaged, and to bring your team together. But it's not free. The maintenance time, which is going to be significantly more in the long term than that initial cost to build, is all of the complexity you're going to introduce in keeping that software running. And most importantly, the opportunity cost is what could you have done if you'd spent that time building scarier dinosaurs instead of working on a camera system. All of this thing compiles together and lands on your organization, and whether or not your organization is mature enough to manage lots of pieces of software. When you write a new system, that comes with responsibility. It comes with ownership policies. Who's going to own that piece of software in the long term? Who's going to decide when it's going to be released? When you take dependencies, when other people start depending on your software, who communicates to them? At Jurassic Park, we had all of the major problems of a major theme park and a major zoo, and our computers were never up on their feet. We'd taken on all of these different pieces of responsibility for the software that we wanted to write, but we weren't really a mature enough organization to effectively manage that. We didn't even have change control. Dennis would just start compiling code in the middle of the day and take down half the system. We could not manage a complex piece of software, and we shouldn't really have tried. To succeed at building lots and lots of complex software, it's going to demand a high level of maturity from your organization. You're going to need to have the processes in place to make sure that you can be effective at it. And so an important question to think about is whether or not your organization is capable of managing lots of pieces of custom software together. Do you have that maturity? And second, do you even want that level of maturity? Because sitting in change control meetings twice a week sucks. It is not a fun activity. In a lot of ways, maturity is just plain overrated. You can, by creating a lot of complex pieces of software, you're going to need to build this level of maturity, which is going to fundamentally change your organization into something different than the fast, lean startup that maybe you started as. Opposed to that, when you take somebody else's pieces of software or you license it, a service from somebody else, you've offloaded some of that maturity that you do not need. You've told some other company, hey, you handle change control, you handle availability, you handle product planning. I don't want to deal with that noise on my calendar every week. I'm going to let some other organization handle it. Which is probably a good transition over to buy. We not only built software at Jurassic Park, we bought a lot of it too. But what does buy mean? The build versus buy question is kind of an old-fashioned-y question. It's kind of a holdover from the days when, we'll either build something or we're going to license it from Microsoft, Oracle, or IBM. And software would come with an army of consultants, then you'd have to install it. And that's not really what buying software is most of the time anymore. A lot of software comes from GitHub. We look for an open source package that solves a particular problem, and we might have to integrate it into our other tools, or we deploy it. We have to figure that out. And so build versus buy isn't really the right word anymore. It's more of build versus use. Because I think a lot of the same problems are going to arise from using somebody else's piece of software, from pulling it down from GitHub and integrating it, as we used to have the same problem if we were to buy it from Oracle, Microsoft, IBM, etc. So let's talk about why we would use somebody else's piece of software rather than building it ourselves. And the most important reason is that buying something, using somebody else's software, is fast. We have a problem, we can solve a problem. Done. We don't have to take a long time to figure out our requirements and build the whole thing out. In the case of our vehicle system, we were able to buy somebody else's software, somebody else's technology, and integrate it. We didn't have to figure out how to design a vehicle. We didn't have to figure out how engines and transmissions and electrical systems for a vehicle work. We were able to buy something and get going fast and focus on the things that were really unique to the Jurassic Park needs. Things like night vision, poison-resistant windows, and T-Rex strength roll cages. We were able to focus on those things that made us unique. But as we all know, buying also sucks. It's never quite the software you need. When you go out and you pull something down from GitHub or you license something from somebody else, it's not exactly what you wanted, right? There's all kinds of things that don't work quite the way you want them to, or that API just feels like a messy shape to you, or the UI is 1,000 checkboxes when you don't want that. It never is exactly what you need because it was built for a wider array of use cases than your company. And unfortunately, when something goes wrong, there's little you can do when that T-Rex-proof sunroof breaks, except try and call Tier 1 support and see if they'll get back to you. We implemented a lot of software at Jurassic Park. Here was a particular project going into implementation. This was our implementation meeting. This was a 3-year project, 24 outside consultants, and we had buy-in all the way from John Hammond all the way down the organization. There were hundreds of planning, design, coordination, implementation meetings to make sure that everything went off just right. It's a complex piece of software that we're bringing in, and we had to make sure that it was going to effectively integrate into the rest of our business. And all of these meetings that require the kind that just eat up your whole day, that your calendar just gets bricked from 8 a.m. to 5 p.m. for weeks on end. We even had a project manager with a shotgun there ready to step in case anything went wrong. But with very complex pieces of software implementation, it ultimately comes down to luck. Despite all the preparation, when it comes down to just deploying that system, as Ray Arnold used to say before deploying software into our infrastructure, hold on to your butts, and we'll see what happens. Despite all of that preparation, over 50% of software implementation projects still fail. There's that old adage in IT about 75% of IT projects fail. I actually couldn't find a source for that, but I could find a source for this from a CIO survey in 2016 that even all the money, all the time, all the preparation we do to integrate software, over half of them still fail. That is awful. How bad are we as an industry that over half the time we don't get it right? It's like we're baseball or something. Our implementation failed, despite our oppressive level of planning. Buying isn't a surefire plan to bring in software either. As you go down the path of buying software, you're inevitably going to have to deal with vendors. Vendor presentations, sales pitches. They bring in a bunch of boxed lunches and show you slides with a bunch of customers on it. Try and convince you that they have the solution to all of your problems. I imagine many of you have sat in those presentations. And even though they say that everything is great, here you can just click install and everything's going to be roses, of course it's not. It's not going to go as smooth as you think it's going to. They'll probably try and sell you on 1 or 2 kinds of software that most vendors kind of fit into these categories. And option 1 is industry standard software. For example, at Jurassic Park, we had a complex engineering flow that we called design to hatch. And it was all of the genetic and hatching efforts that would go in from designing a dinosaur to hatching the first one. And in some cases, some steps of that, we had pretty standard things we do, like egg management. We needed to manage the eggs, make sure we rotated them on a certain schedule so that they wouldn't get too hot and everything would come out. But that wasn't all that different than how other industries in the world manage eggs. And we were able to buy a piece of software from somebody else that already knew how to do this. We didn't have to figure out how we needed to rotate the eggs, on what schedule, or anything like that. We were able to buy from a company that services chicken farms and just adapt that software to our need. It was industry standard for chicken farms, and we were able to just bring it in and go really fast with it. Most software that we buy or use assumes a certain flow of work. There is a process assumed in its construction. And when you buy a piece of software, you can often get the advantage of just taking somebody else's process and not needing to invent it yourself. Your organization can go faster because you're just taking the lessons learned from another organization that's already figured out how to do something well. We saved a lot of heartache by changing our design to hatch process to just match what this piece of software already did. And in other cases, by adopting standard operating systems, we were able to onboard new interns into our IT infrastructure, and they were quickly able to understand what the system did because it was an industry standard operating system with an industry standard structure for how we arrange things. In other cases, software pitches itself as being highly configurable to your needs. They have so many options, so many switches and configuration options that they can make their software be whatever your company, whatever your process wants it to be. This fit into our process like in our genetics testing structure. We need software that could adapt to our changing needs, and we could customize and configure it to what we need it to be. A good analogy for maybe this crowd would be Atlassian's Jira product, which is a ticketing management system. And it's infinitely configurable. It can be transformed into be whatever your organization wants it to be. You can transform that process to match, or you can transform that technology to match your process. Unfortunately, if your process is shit, Jira will just make your process go bad even faster. And so when you buy a configurable piece of software, you have to think for yourself on how the best way to manage that flow of work is. Of course, regardless of which path you choose, an important thing to think about is vendor lock-in. If you buy a piece of software, you need to think about this, because the more you customize a piece of software for you and for your needs, the more you take advantage of their system flexibility and integrations, the more they lock you in to continuing to use that vendor, the more expensive it's going to be to ever leave them. Recreating all that configuration and tailoring to your system is expensive. And vendors know about this. They actively build for it. It's a concept that vendors call being sticky. How sticky is their piece of software? How much are they going to latch on to a customer and make it hard for them to ever leave? And this isn't like even a nasty term. Like Azure is all about this. AWS is all about it. If you start building your new system in AWS, you can't just pick it up and leave. You've built to the constraints of that platform. You have built to their APIs with their client libraries, with their way of doing things. They're intentionally doing that to make sure that you can't leave later. And all the vendors are doing it, but it's something that we all need to think about. There's an example for Jurassic Park. We used Salesforce.com for a number of our pieces of software. And if you've developed in Salesforce.com, they use their own proprietary programming language and their own proprietary SQL query language called Apex and Sockle. And so when you build a complex piece of software there, you've been bound to their system. You can't take it out and go anywhere else. You've literally written your entire application in a language that will only work on their platform. And so it's made it so sticky that you can't leave without deciding that you are going to rewrite your system from the very beginning. Of course, because buying, installing, and integrating software often sucks, we have a tendency to overbuild. We built our own monitoring systems. We built our own tour operations. We built our own telephones, our own weather, our own video surveillance, our own door locks. We overbuilt a lot of things that we didn't need to at Jurassic Park because we had not invented here syndrome. If we hadn't built it or personally chosen it, we didn't want it. And it was just, we pushed it out of the organization. One of the great examples I have that led to the not invented here syndrome is a particular piece of software that we used called Raptor. Now, Raptor was a hot tech startup. They were featured in all the latest tech press. The community buzzed about them. Raptor's whole thing was they were going to be a security company that could secure the most unsecurable assets in the world. And we we had some volatile assets at Jurassic Park that we needed to make sure that we protected. Raptor was all pumped up by the venture capitalists that had poured money into them. But like many other hot tech startups, they're not sustainable at their core. Lots of great software vendors are unsustainable early on, where they take more money and they don't actually make enough money to pay all the people forever. But trouble can happen if something goes wrong. Something like this. There was an incident in the JavaScript community a while ago, back in 2016, called LeftPad. Did anybody hear about LeftPad? So there was this core piece of software that a lot of companies depended on, and then one day it just disappeared. But unfortunately, Raptor depended on LeftPad. And like many node projects, it took downstream dependencies, and so this piece of software, just disappeared one day, leaving all of these systems to kind of break. All the builds broke, nothing could progress. And so when the project disappeared, the Raptor infrastructure failed catastrophically, and many of their customers were impacted, including Jurassic Park. And the liability of that incident killed them. And one day, on a Thursday, we woke up and TechCrunch had reported that Oracle had bought the people from Raptor, and they were just going to be gone. And like many hot tech companies, they can disappear like that. One day you feel like they are on top of the world and everybody's singing their praises, and the next day they're sold off and closing down. And so the sustainability of Raptor had some serious consequences to Jurassic Park when we could no longer use their system. And so when you're thinking about a vendor, you have to think about whether or not they're profitable. Are they making enough money to sustain themselves? Are they reputable? Are they going to be able to support the promises they're making to you? And this is just as relevant for an open source project as it is for a commercial piece of software. If you're depending on a piece of open source software existing, if your company has built itself around this piece of open source, and it's just being written by some poor developer in their basement that is not getting paid and is just getting abuse on the internet for not building features fast enough, that's unsustainable. One day, that developer is going to rage quit and walk away, or they're going to delete the project and walk away. If they're not sustainable, that's not going to be around when you need it. So if you are depending on it, you should either help them get to sustainability or take it on yourself. So I talked about some things that we built and some things that we bought and how it kind of failed for us on both sides. The first Jurassic Park, we got some mud in our face. We failed as a project. I failed. 4 of our people from our core team are dead. Our lawyer is dead. Project manager's dead. Mr. Arnold is dead. And Dennis is dead. The Dilophosaurus Factor killed us. But it's only 4 people. How can we do better? What can we learn from this? In the first Jurassic Park, I think I got a little too far away from the technology in my VP role. I didn't ask the right questions to keep our systems on track, our developers working on the right things. And so I was put together this list of questions that I think is important. The first, what's the impact of failure of a system? Let's say, hypothetically, everything goes wrong. I know it's probably not going to happen, but humor me. What is the impact of failure if this system goes offline? Does your business lose money? Is an engineer inconvenienced? Or do people die? That's an important question, and it should factor in to how much time and effort you go into thinking about it. We should focus on the decisions that are going to involve people's lives or the business losing large amounts of money, not so much about whether or not a developer is inconvenienced. That kind of decision can be left to, hey, let's just do whatever is appropriate for that instance. Don't get sucked into analysis paralysis for small decisions. Don't sweat the small stuff. Second, when we're thinking about a problem, about building a piece of software to solve something, Does this software give us a competitive advantage or a competitive parity, is what a lot of our MBA consultants would say. Of course, that's not really that's a very businessy way of saying it. I prefer what another one of our consultants, Mr. Dylan Beatty, said, is that if you couldn't sell it, buy it. I think that's a much more concise way of doing it. But we need to adapt that to the open source model of contribute it. If you don't think a particular problem would be novel enough, interesting enough, that you could either build a company around it or put it online as a GitHub project that other people would use and extend and be valuable, if you don't think it passes that bar, then it might not be worth your time to build it. It's not interesting enough. If you think that you have the best way of converting a document into PDF, you're probably wrong. You probably can just use somebody else's tool, either open source or buy a package from somebody, to just solve that problem for you. It is probably not novel enough. And I think this is a good test. It's a good rule of thumb when you are deciding whether or not you want to build or buy something. The third question, we should understand what our bias is. This is a picture of a mob programming session that we had of some of Dennis's systems after he left. While we're doing the review of his code, we noticed there was this inherent bias in his choices, a bias to build. There were over 3 million lines of C code all wound up together, doing everything himself. He didn't call out to any external services. He didn't depend on any external libraries. He built every single thing himself, which caused a lot of complicated bits of code, a lot of complex integrations that might not have been fully necessary. We had a bias of building things that we probably shouldn't have in the first Jurassic Park. And I think recognizing that bias is important. If our default decision is we're just going to build it, then you're going to end up building way more than you should. Often, upper management has the opposite bias, is they don't want to build anything, they want to buy everything. And that's important to recognize too. You need to find that proper middle ground so you can have the conversation about whether or not something is novel enough and not just going with your bias. 4, understanding what could we do with our time instead of this. If we're going down the approach of building it, well, is this the best use of our time? Could we, instead of building a new security system, could we build a bigger, scarier dinosaur? I mean, I think that answer is clear. I think we want to build a bigger, scarier dinosaur. So if it comes down to that decision, we can focus that. When you're making those decisions in your organization and you want to build your own PDF viewer, your own security system, your own monitoring software, think about, is that the best use of our time? Or should we spend it on our core problem, on our core product for our core customers, give them something new, something powerful, something amazing and scary that's going to terrify them? I think that's where we should spend our time. And the 5th question is whether or not it is sustainable. And I think this is an important question to ask for both building and buying software. If you're building it, you need to think about sustainability of, do you want to manage this software for its lifetime? You're going to own it. You're going to own the servers it gets deployed to. You're going to own the versioning control. You're going to own who patches it, where's the documentation, where's it going to live. That's all you. Are you going to be able to sustain that in your organization? Or if you're buying a piece of software or using it, is where it came from sustainable? Is that company still going to be around in 5 years when you need them? Is the person who's the primary author of that open source package, are they teetering on the brink of rage quitting and just disappearing and not being available when you need them? Who is supporting the open source packages that we depend on? So these 5 questions are factoring in to the next time, which I alluded to earlier. The next time, the next Jurassic Park, we're going to get this right. One of the problems that we faced with the last Jurassic Park was that it was too remote. The place where we built it, it was just too remote. It was too hard to get to. We couldn't respond to the problems on the ground. And so I'm very pleased to share that we're finalizing plans to build the next park right nearby in the hills of Portugal. We're actively hiring, especially in Raptor operations. So if you're interested, please come and see me afterwards. Unfortunately, we cannot offer life insurance for that position. Another problem is that last time our system it wasn't very flexible. It was too much, it was just piles and piles of C code that nobody could ever decipher what's happening. And so next time, we're going to build it in JavaScript. And I think this is going to solve a lot of our problems. We're going to use modular JavaScript, and we're going to bring in lots of different things so that the modules that we think are unique and important to us, we can build. And the modules that we think are not our core, we can leverage open source packages, or we can call out to software service providers to do the things that we don't think are our core. And I think this is going to really enable a lot. We have some new developers coming on. We have a new developer, Newman, fresh out of the code school after leaving the United States Post's office. He's got some exciting ideas about distributed systems that we're going to try. And we're putting our lessons to use. We're already applying these ideas on answering these questions about build versus buy. And I want to share an example with you about how we're going to deal with all of that JavaScript. Being that the new Jurassic Park is going to be built on JavaScript, like most JavaScript apps, it's going to break unexpectedly from time to time. And so for the next part, we're trying to figure out how we're going to do this. And so we started with, okay, maybe we should build this. Let's talk about how do we build this piece of software. And so it would start with building out a little bit of JavaScript. We need to write some JavaScript to capture the errors, capture problems that would be emitted. And we're going to need to put them somewhere. So we can set up a database somewhere. We'll have to build a dashboard so that we see where are errors happening and dig into them and see what the stack traces are. But then we also should have like some anomaly detection when new things start happening and maybe alerting. Maybe we should call out and tell us when something's breaking. But we also need backup and security, and we have to put this on some infrastructure somewhere. And then what happens if our monitoring goes down? Who monitors the monitoring? How do we do that? Do we need monitoring of the monitors of the monitoring? And how deep does that go? So that's one path. We could do this. There's also another option. There's a bunch of vendors out there that do something like this, like Todd Track.js, who introduced me. So we ran it back through the calculator, and Newman gave me like some estimate on what it would take. He thinks he can build it himself, but it'll take him 4 weeks. We're paying Newman a little bit less than Dennis. We're only paying him $100,000. But we still think it's going to take about 1 day a month in order to maintain the system, make sure that we're supporting new browsers, that new things are working. Or we could buy it, we could license it for about $3,000. But if we run those numbers, it still never really pans out. It's going to cost us over $7,500 to build it, and another $3,000 every year just in maintaining it. And that 1 day a month just continues to add up. And so we never really get a positive ROI off of building it. And so it comes down to whether or not our developers are excited. And not all developers are excited about building monitoring software. But on either path, we need to think about sustainability. If we build this piece of software, can we maintain it? Are we willing to continue diverting time from that new Tyrannosaurus project to update to the next version of Chrome? Or if we go with a vendor like Track.js, how do we know they're still going to be around when we need them? How do we know that company is still going to be there? One thing to consider is financial health, as I mentioned before, about whether or not they are profitable, they're going to stick around, and if they have outside investors. And in chatting with Todd earlier, they said that they are entirely profitable, and they have no outside interests and no debt, so they will be around for a considerable amount of time. So one thing to think about is that opportunity costs. Should we spend our time building monitoring software or more time building bigger, scarier dinosaurs? And I think we're coming down on the side of we want to buy monitoring software so that we can build scarier dinosaurs. I think that's what the people want. And Newman is already kicking the tires, and I think it's going to work out well. So let's kind of wrap this up. So we talked about build versus buy today. We talked about some of the problems that happen when you build software, some of them that happen when you buy software, and what are some things to think about when you're trying to make this decision? Because we all are making this decision pretty often. As we're working through a problem in our day-to-day jobs, you'll often stumble into something and say, oh, is there an open source package that does this for me? Can we sneak this into the next sprint? Where can we build this? You're implicitly making a build versus buy decision right there. And so when you do, you should think about, is the decision I'm making sustainable and a good idea for the company? And so we need to ask ourselves these questions. What's the impact of failure? Don't spend a lot of time thinking about a problem if the impact is trivial. Is this product, if we built a thing that solved our problem, is it novel enough that we could sell it or that we could contribute it back and people would use it as a good test of whether or not something is interesting? What is our bias? Are we just thinking we're going to build it and move on, thinking we're going to buy it and move on? Recognize that so you can ask the rest of the questions. What could you do with your time instead? If you didn't spend your time building your next monitoring company or building the security system, what could you do in your organization instead? And finally, on whichever side you're coming down, is it sustainable? If you're going to deploy a new piece of software that you built into your organization, are you going to be willing to own it for the next 3, 5, 10 years, however long it's going to operate? Or if you're buying a piece of software, do you know who you're buying it from? Do you know if they're going to be around to add the features you need to pick up the phone when something's going wrong? So, in the immortal words of Ian Malcolm, there it is. Thank you for Todd Gardner for inviting me here to share the lessons from Jurassic Park. I hope you can all go forward and not make the same mistakes we did. I'm going to be available up here for a while to answer questions or chat about whatever problem that you're running into, questions, concerns, or if you're interested in submitting a Raptor handling application. Thank you very much.